In section 9.2 we looked at multiplying polynomials, and now in section 9.3 we're going to look at a few special cases of multiplying polynomials. So first of all, we could have a polynomial, in this case a binomial, that's a perfect square. So when we take a plus b and square it, it turns out we get this nice little form a squared plus 2ab plus b squared. In other words, square the first term, take 2 times the first term times the second term, and then square the second term. And if you were to make a square of this and see how it works out that way, you'll see, I think, why we get that form. So if we have a plus b in both the row at the top and the column on the left, so a plus b, a plus b. A times a is a squared, a times b is ab, a times b is ab, and then b times b is b squared. And so notice that we get a squared and then two ab terms. These are exactly the same, and then b squared. Or if we have a minus b, it's going to be very similar, just that we have a negative sign. And let's see, so we have a minus b, a minus b. We still get a squared here, and now the difference is we're going to get a negative ab here. So negative ab, negative ab. So there's where we get our minus 2ab. And then when you take negative b times negative b, it's a positive b squared. Alright, so these are good formulas to remember, and if you don't memorize them, that's okay. You can always set up a square or use the FOIL method. You could write this out, a plus b times a plus b, and use the FOIL method. We also have the case of a sum and difference. So here we have a plus b, there's our sum, multiplied times a minus b, there's our difference. So it's the same two terms in each case, it's just that in one case we're adding them and in the other case we're subtracting. And notice that the middle term, what would normally be our middle term, drops right out. Okay, so let's look at this one. Here we have a plus b, and then that would mean in our column we have a minus b. So we still get a squared here, and then we have a times b is ab, and then a times negative b is negative ab, and then b times negative b is negative b squared. And so notice that here we have an ab and a negative ab, and these two cancel each other out, and that's why we end up with a squared minus b squared. So you want to look for these special cases that will help simplify your life a little bit if you happen to run into them. So let's look at a few examples. Find each product. So we have x plus 4 squared. So we know that from our shortcut here, this is going to be equal to, oops, that's a 2, the first term squared, so that's going to be x squared plus 2 times x times 4. I'm going to go ahead in this case and write that out. 2 times x times 4 plus, and then our last term squared, so 4 squared. So this is equal to x squared plus 8x plus 16. Alright? And notice here, if you see this kind of a trinomial, you have a leading coefficient of 1 here. Notice that the constant is a perfect square. If you take the square root of 16, and that's 4, multiply that by 2, you get 8. That's going to help you, hopefully in a future section, to recognize these perfect squares when they appear as trinomials. But that's jumping ahead a little bit. So let's look at this form. We have 3x minus 4 squared. Okay, so we're going to square the first term. So I'm going to put 3x in parentheses squared plus 2 times 3x times negative 4. So 2 times 3x times negative 4. And then plus 4 squared. Alright, and we end up with, remember we need to square the 3, not just the x, so we get 9 x squared, and then 2 times 3 times negative 4. 2 times 3 is 6, times negative 4 is negative 24, so negative 24x. And then when we square negative 4, if you could also put negative here, put it inside parentheses, but we know when we square it that we end up getting a positive. Okay, so here we have 9x squared minus 24x plus 16. Okay, number 3. Same idea here, where we're going to, I'll rewrite this first, but we're going to square the first term. So this is equal to 2x squared squared. Now notice the difference here is that we have x squared rather than x inside the parentheses here, but that's okay. And then plus 2 times 2x squared times negative 4. So 2 times 2x squared times negative 4 plus that last term squared, so plus 4 squared. So this is equal to, so we need 2 squared is 4, x squared squared, multiply the exponents because we have a power of powers, and this will give us x to the 4th. Now we have 2 times 2 is 4 times negative 4 is negative 16, so minus 16x squared, and then our constant is 16. All right. Let's look at number 4. Here we have negative 3x plus 4y, and we're going to square that whole thing. So we'll take the first term, square it, plus 2 times a, which is negative 3x, times b. So notice we have two variables showing up here, but that's okay, 4y, and then plus, and our last term, 4y, is going to be squared. So we get negative 3 times negative 3 is 9. X is squared, so positive 9x squared. Now we have 2 times negative 3 is negative 6, times 4 is negative 24, and then for the variables we have x times y, so minus 24xy plus, remember we have to square the 4 to get 16, and then square the y. Okay, so we end up with an x squared term, an xy term, and a y squared term. No problem, right? Alright, here we have a sum times a difference. So remember the shortcut for this is we're going to have that first term squared minus the second term squared. Okay, so we get x squared minus 36. If you don't remember that shortcut, you can still work this out in either a table/box method or using the FOIL method, and you should still get the same result. But if you recognize that there's a special pattern here, there's a shortcut for you. Alright, and number 6. Again, we have a sum and a difference. It doesn't matter which order they're in. Here we have the difference first, then the sum. Same result though. This is going to be equal to, our first term is 2x, that will be squared, minus our second term is 3y, which also gets squared. So we have 2 squared is 4x squared, minus 3 squared is 9, and y gets squared as well. So there you have it. Keep your eyes open for those special cases of multiplying polynomials. Good luck.